Algebraic fundamentals 1. Basic definitions. Topics to cover are variables, constants, coefficients, operator and operand, term, expression, exponent, nominal, and degree. Variables. A variable is a symbol for a number. We don't know yet. So a variable is a symbol for a number we don't know yet. For instance, if I create a bucket, I can call that bucket X. And X can be any number put into that bucket. So X could be 2, X could be 3, X could be 4. And therefore, we say a variable number would go into that bucket. It could be any number. And that bucket could be called Y or could be called Z. So the most common name for variable or the most common variables or names for variables are X and Y. It's a bit like when someone is born, that person gets to be given a name. So you could call the new variable X or Tom or Jerry. So you don't have to call it X. We call it X because it's easy to write. You can call it anything you like. Well, be careful with rude names. Okay, so that's variable. Some variable you may have seen are like F equals MA. F is a variable. M, well, it's another variable, but in that case, M could be a fixed number. So it's a kind of constant. But A, it will be a variable. Another one you may have seen will be things like Y equals X squared, or even you may have seen Y equals 2 to the power of X. So the variable in this case are X and Y. Those are the variable. So variable or variables are usually what we solve equations to find. That's what we solve equation to find. So therefore, a variable can have more than one possible values. As we said, the word variable. So it can have variable numbers. So it can have variable numbers. So that is what a variable is. Variable numbers. Constant. Constant is what we called a fixed number. A constant is a number on its own. That's what a constant is, a number on its own. Example, i.e., a 2 is a constant on its own, or any other number, 4, 24. That will be a constant value. So constants are fixed number. So constant, better write down, constants are fixed number. Unlike variable, they can be variable numbers. So if you have a bucket, you can name that bucket give it a letter, say A, and A is a placeholder to represent the number that will be in the bucket. And it will not change. Whatever that number is, it will stay the same throughout. So in this case, but constants are fixed number, but they, so let's say constants are fixed number, but they can be represented by letters as a placeholder, So they're waiting for what that number to be. So let's choose a famous constant that we know, pi, which is pi in mathematics, is equal to 3.14159264, and it goes on. But when I was younger, I'm still young, a constant can be represented as, can be represented as 22/7. And that's roughly 3.142. E is another number. E is also a constant, which represents 2.718218. Take that back. 281828, and it goes on. So that's what E represents. It's a letter that represents that number 2.7182, and it goes on. So sometimes we can use, letters, like I said, to represent a constant. So A can be a constant, B can be a constant, C can be a constant. For instance, in an equation of quadratic equation where you have ax squared, this is the general equation for quadratic, plus bx plus c, and a is a placeholder, likewise b and c, to represent the number to be. So therefore, give an example, would be 3x squared plus 4x plus 2. In this case, a equals 3 as a constant. It's a fixed number, a equals 3. B equals 4. And C equals 2. Coefficient. Coefficient is a number used to multiply a variable. Or you could say it's a number in front of a variable. For example, I'm going to draw a small table. So coefficient and variable. So if I have a number, say x. By the way, x is actually equals 1x. That's what that meant. If you say x, actually, you actually meant 1x. So the coefficient is a number in front of x. So that's 1. And the variable here is x. If I write for x, you can guess what the coefficient is. So think about it and write down what coefficient is and the variable. And then you can pause and then write it yourself and see if you get it. In this case, coefficient is 4 and the variable is x. What about if I write 3t? What is the coefficient and what is the variable? Pause, write it down, and then check. So coefficient is 3, variable is t. What about 8x squared? Again, pause, and then write the coefficient and the variable, and then check again. The coefficient is 8, and the variable is x. Not x squared, but it's x. What about 2y cubed? The coefficient here is what? 2, and the variable is y. So if we look at a quadratic equation again, the general equation of quadratic, it's ax squared plus bx plus, let me put it this way, ax squared plus bx to power 1 plus cx to power 0. Anything to power of 0, x to power of 0 is 1. In fact, anything to power of 0 is 1. Okay, let me write it. Anything to the power of 0 equals 1. So in this case, the coefficient, that's a, not 9, the coefficient in front of x squared, the coefficient of x squared is a. And the coefficient of x is b. And the coefficient of x to power naught is c. But if I write this equation clearly, it will be ax squared plus bx, because x to power 1 equals x, plus c. As I said, x to power 0 equals 1. 1 times c is c. So you can now see the coefficient of x squared is a, the coefficient of x is b, and the constant, which actually is the coefficient of x squared, x to power 0, is c. So the numbers that go in front of this equation, in front of these coefficients, are also constant values. So a coefficient is actually a constant number in front of a variable. So if I write 4x squared plus 3x plus 5, the constant or the coefficient of x squared is 4. So that means a equals 4. The coefficient or constant of x is 3. That means b equals 3. And the constant c equals 5. Operators and operands. Operator is a symbol such as plus, literally plus, times minus divide and so on. That's what operators are. An example would be 2 plus 3. And the operator here in this statement or expression, the operator here is plus equals operator. And this operator plus is operating on the operand. So the operand are 2 and 3. So operators operate on operand. So what's on the side of the operator is what we call operand. What about 2x plus 4? The operator is plus, that's the operator. And the operand is or are 2x and 4. Those are the operand. Term. A term is either a single number or a variable or numbers and variable. Multiplied together. So that's what a term is. You could have one term. That's a one term. Literally 1 is a one term. Or 2 is a one term. Any number would be a one term. So 23, one term. If it have 2x, that's still one term, because you can see 2 and x multiply together. You may even have 2x cubed. That's one term. So really, a term can have 1 or 2 or 3 parts to it. And so I'm going to do this parts now. So you get one part like that, another one, and one on top there. So that's what terms look like, to be honest. And this is what we call a term. And in this case, I could have, let's put 3 there. That's a constant. Let's put a variable there and a number in the power. So when you write 3x squared, that's a term, one term. So what I've written in terms of term is, so a term, a proper expression for it would be, I'm going to write this down, a coefficient which is the number in front of the variable. So I'll write another little box for the variable next to it. And I put on top here what we call power. And the posh name for power is exponent or index. Exponent or index. So a power is exponent or index. So that's what a term is. A term is a coefficient, variable, and exponent together. So power is equal to exponent which is also equals index. So a term can be a constant or coefficient. A term can be a coefficient variable with power. For instance, 3t squared is a term, one term. But if I have 3t squared plus 4, that will be two terms. So if I have 3t squared plus 5t plus 4, that will be three terms. So that's one term, two terms, three terms. So it's important to know these things because it does help you to understand the communication in mathematics, and not just maths, science, or even any other numerical analytical process. Expression. Expression is a group of terms like we saw earlier. The terms can be separated by an operator. So the term can be separated by an operator such as plus or minus. So give an example. 8, write it clearly, 8x squared plus 3x plus c, or 6 rather. This expression has three terms. So these are three terms. One term, the second term, and the third term. So it's got three terms. But this is also an expression together. So all these grouped together is an expression. Let's write another expression, and this time we put equal sign. So I have 4x plus 2 equals 3. And these are three terms, 1, 2, and 3. Those are three terms in this case. But the expression is here. Those are the expression, and the whole thing, it's called equation. It's called equation because it has an equal sign in it. Because it has an equal sign. But the 4x plus 2 is an expression. Exponent. Exponent basically is power in an expression or equation, which is also actually equals index. So the exponent is the power. For instance, 8 to the power of 2. The 2 here is the exponent, and the 8 here is the base. So base 8 to power of 2, or base 8 to exponent of 2, or base 8 to index of 2. Another example would be ax cubed. Don't forget the a is the coefficient or the constant in front of the x cube. So a is the coefficient, the x is the variable, and the 3 is the exponent. Nomial means term. We can have many terms, hence we have many nomial. So many nomial is what we called polynomial. So an example of a polynomial would be an expression ax to the power of 0 plus bx to the power of 1 plus cx to the power of 2 plus dx to the power of 3 plus, and it goes on. So that's what we call polynomial. So that means many terms. In this polynomial I've written down, I have got 1 term, 2, 3, 4. So that's 4 terms. Hence it's called polynomial. A single polynomial, or a single term, or a nomial, so that it's from, this is a monomial. And if you have 2 of them together, that'll be binomial. So that and that will be binomial. And if you have all 3 together like that, that will be trinomial. So all 3 of them, so 1 term, it's a monomial, monomial. 2 terms, it's a binomial, and 3 terms is a trinomial. So a quadratic equation, a general quadratic equation, which is ax squared plus bx plus c, has 3 terms. So it is a trinomial. Let me just write some more examples. If I have 3x squared, 5x minus 2, 3x plus 5y squared minus 4. So this one is monomial, and this is binomial, and this one is trinomial. And this is 1 term, 2 terms, and 3 terms. If you have more than 1, if you have 2 or more terms, it's called polynomial. So that'll be 2 or more terms, it's called polynomial. Just remember that the ax to the power of 0, because anything to the power of 0 equals 1, and x to the power of 1 equals x. Therefore, ax to the power of 0 is a, plus bx to the power of 1 is bx, plus cx squared plus dx cubed. Degree of polynomial. Degree of polynomial implies the highest exponent in the polynomial. An example would be ax squared plus bx plus c. In this expression, because there's no equal sign, hence it's not an equation, it's an expression or statement. It's got two operators, two pluses, and it's got the operand, 3 operand. The degree of polynomial is 2, because 2 is the highest exponent. So 2 here is the degree of polynomial. Let's try another example. Ax cubed plus bx to the power of 5 plus dx to the power 4. What is the degree of polynomial? Pause, think about it, and then write down the degree of polynomial. The degree of polynomial is 5, because 5 is the highest exponent or power. So the highest exponent is 5, and that's the degree of polynomial. In this case, the word degree actually is referring to how many factors will it have. So the first one here will have 2 factors because it's got two degree of polynomial. The second equation here, expression here, will have 5 factors because it's got 5 degree of polynomials. So the factors, that's a factor, 1, 2, second factor, 3 factor, 4, and 5. So that's what that meant. Quadratic has 2 degree of polynomial, hence it has 2 factors and 2 roots. The second equation has 5 degree of polynomial, hence it's got 5 factors and 5 roots. Roots are the solutions. So roots equals solutions. That means where it crosses the x-axis. It must have crossed the x-axis 5 times. So it crosses the x-axis when you plot it 5 times. Quadratic will cross the x-axis how many times? I'm sure you're saying it crosses the x-axis 2 times. because it's got 2 degrees of polynomials, 2 factors, and 2 roots. Right, so now we've covered all 9 of them. We know what variables are. Variables are variable numbers. They are letters or placeholders that can have any values. So they are placeholders that can have any values. So they can have any values, or you might call it variable numbers. So any values or variable numbers. A constant, on the other hand, can only have a fixed value. Fixed value. A coefficient is a fixed number, or it's a constant in front of a variable. So, well, a variable, obviously, we said is going to be either x or y. A constant can be 2 or pi or e. A coefficient is a number in front of a variable. So if you have 2x, so coefficient is 2. If you have 3x cubed, or say 3x squared, the coefficient is 3. If you have 5x cubed, the coefficient is 5. So those are the coefficient. A number in front of a variable. They are constant in front of a variable. Operator operates on operand. So 2 plus x, the operator is plus, and the operand are 2 and x. So the operator is plus and the operand are 2 and x. Term. A term usually consists 3 parts, which is the coefficient, the variable, and the exponent. So that would be one term. And we said one term is called monomial. 2 terms will be binomials, and 3 terms will be trinomials. And if you have many terms, we call it polynomial. So a good example of a term would be ax squared plus bx. These are 2 terms. 1 term, 2 terms. There's 2 terms. Expression. Ax squared plus bx is an expression. Exponent. Exponent is the power. Exponent equals power or index. We can use whichever one you like. Read questions carefully. See what they say in the statement before you attempt. They might use index or power or exponent. Nomial. A nomial is equal to term. That's what nomial means. And so one term is monomial. 2 terms is binomial. So actually, let me write it in a way that makes sense. So if I have 1 term, that will be monomial. If I have 2 terms, that would be binomial. And if I have 3 terms, 2 terms and 3 terms, 3 terms is trinomial. So a 1 term is ax squared, 2 terms is ax squared plus bx, and 3 term is ax squared plus. So binomial, obviously, and trinomial is ax squared plus bx plus c. Degree. Degree is the highest exponent in a polynomial, or in a many terms. So a degree is the highest power. So exponent is power or index. So a degree is the highest power in a polynomial. In a quadratic, the highest power is 2. Hence, the degree of polynomial is 2.